Socio-technical systems in organizational development is an approach to complex organizational work design that recognizes the interaction between people and technology in workplaces. The term also refers to the interaction between society's complex infrastructures and human behavior. In this sense, society itself, and most of its substructures, are complex socio-technical systems. The term socio-technical systems was coined by Eric Trist, Ken Bamforth and Fred Emery, World War II era, based on their work with workers in English coal mines at the Tavistock Institute in London. Socio-technical systems pertains to theory regarding the social aspects of people and society and technical aspects of organizational structure and processes. Here, technical does not necessarily imply material technology. The focus is on procedures and related knowledge, i.e., it refers to the ancient Greek term logos. Technical is a term used to refer to structure and a broader sense of technicalities. Socio-technical refers to the interrelatedness of social and technical aspects of an organization or the society as a whole. Socio-technical theory, therefore, is about joint optimization, with a shared emphasis on achievement of both excellence in technical performance and quality in people's work lives. Socio-technical theory, as distinct from socio-technical systems, proposes a number of different ways of achieving joint optimization. They are usually based on designing different kinds of organization, ones in which the relationships between socio and technical elements lead to the emergence of productivity and well-being. Overview. Socio-technical refers to the interrelatedness of social and technical aspects of an organization. Socio-technical theory is founded on two main principles. One is that the interaction of social and technical factors creates the conditions for successful organizational performance. This interaction consists partly of linear, cause and effect, relationships and partly from non-linear, complex, even unpredictable relationships. Whether designed or not, both types of interaction occur when socio and technical elements are put to work. The corollary of this, and the second of the two main principles, is that optimization of each aspect alone tends to increase not only the quantity of unpredictable, undesigned relationships, but those relationships that are injurious to the system's performance. Therefore, socio-technical theory is about joint optimization, that is, designing the social system and technical system in tandem so that they work smoothly together. Socio-technical theory, as distinct from socio-technical systems, proposes a number of different ways of achieving joint optimization. They are usually based on designing different kinds of organization, ones in which the relationships between socio and technical elements lead to the emergence of productivity and well-being, rather than the all-too-often case of new technology failing to meet the expectations of designers and users alike. The scientific literature shows terms like socio-technical all one word, or socio-technical with a hyphen, socio-technical theory, socio-technical system and socio-technical systems theory. All of these terms appear ubiquitously, but their actual meanings often remain unclear. The key term, socio-technical, is something of a buzzword in its varied usage can be unpicked. What can be said about it, though, is that it is most often used to simply, and quite correctly, describe any kind of organization that is composed of people and technology. But, predictably, there is more to it than that. Principles. Some of the central principles of socio-technical theory were elaborated in a seminal paper by Eric Trist and Ken Bamforth in 1951. This is an interesting case study which, like most of the work in socio-technical theory, is focused on a form of production system, expressive of the era and the contemporary technological systems it contained. The study was based on the paradoxical observation that despite improved technology, productivity was falling, and that despite better pay and amenities, absenteeism was increasing. This particular rational organization had become irrational. The cause of the problem was hypothesized to be the adoption of a new form of production technology which had created the need for a bureaucratic form of organization. In this specific example, technology brought with it a retrograde step in organizational design terms. The analysis that followed introduced the terms socio and technical, and elaborated on many of the core principles that socio-technical theory subsequently became. Responsible autonomy. Socio-technical theory was pioneering for its shift in emphasis, a shift towards considering teams or groups as the primary unit of analysis and not the individual. Socio-technical theory pays particular attention to internal supervision and leadership at the level of the group, and refers to it as responsible autonomy. The overriding point seems to be that having the simple ability of individual team members being able to perform their function is not the only predictor of group effectiveness. There are a range of issues in team cohesion research, for example, that are answered by having the regulation and leadership internal to a group or team. These, and other factors, play an integral and parallel role in ensuring successful teamwork, which socio-technical theory exploits. The idea of semi-autonomous groups conveys a number of further advantages. Not least among these, especially in hazardous environments, is the often felt need on the part of people in the organization for a role in a small primary group. It is argued that such a need arises in cases where the means for effective communication are often somewhat limited. As Carvalho states, this is because operators use verbal exchanges to produce continuous, redundant and recursive interactions to successfully construct and maintain individual and mutual awareness. The immediacy and proximity of trusted team members makes it possible for this to occur. The coevolution of technology and organizations brings with it an expanding array of new possibilities for novel interaction. Responsible autonomy could become more distributed along with the team themselves. The key to responsible autonomy seems to be to design an organization possessing the characteristics of small groups whilst preventing the silo thinking and stovepipe neologisms of contemporary management theory. In order to preserve intact the loyalties on which the small group depend, the system as a whole needs to contain its bad in a way that does not destroy its good. In practice, this requires groups to be responsible for their own internal regulation and supervision, with the primary task of relating the group to the wider system falling explicitly to a group leader. This principle, therefore, describes a strategy for removing more traditional command hierarchies. Adaptability. Carvajal states that the rate at which uncertainty overwhelms an organization is related more to its internal structure than to the amount of environmental uncertainty. Sitter in 1997 offered two solutions for organizations confronted, like the military, with an environment of increased complexity. The first option is to restore the fit with the external complexity by an increasing internal complexity. This usually means the creation of more staff functions or the enlargement of staff functions or the investment in vertical information systems. Vertical information systems are often confused for network-enabled capability systems, but an important distinction needs to be made, which Sitter et al. Propose as their second option. The organization tries to deal with the external complexity by reducing the internal control and coordination needs. This option might be called the strategy of simple organizations and complex jobs. This all contributes to a number of unique advantages. Firstly is the issue of human redundancy, in which groups of this kind were free to set their own targets, so that aspiration levels with respect to production could be adjusted to the age and stamina of the individuals concerned. Human redundancy speaks towards the flexibility, ubiquity and pervasiveness of resources within NEC. The second issue is that of complexity. Complexity lies at the heart of many organizational contexts. Tristan Bamforth could have been writing about these with the following passage: A very large variety of unfavorable and changing environmental conditions is encountered, many of which are impossible to predict. Others, though predictable, are impossible to alter. Many types of organizations are clearly motivated by the appealing, industrial age, rational principles of factory production, a particular approach to dealing with complexity. In the factory, a comparatively high degree of control can be exercised over the complex and moving figure of a production sequence, since it is possible to maintain the ground in a comparatively passive and constant state. On the other hand, many activities are constantly faced with the possibility of and toward activity in the ground of the figure-ground relationship, the central problem, one that appears to be at the nub of many problems that classic organizations have with complexity, is that the instability of the ground limits the applicability of methods derived from the factory. In classic organizations, problems with the moving figure and moving ground often become magnified through a much larger social space, one in which there is a far greater extent of hierarchical task interdependence. For this reason, the semi-autonomous group, and its ability to make a much more fine-grained response to the ground situation, can be regarded as agile, added to which, local problems that do arise need not propagate throughout the entire system because a complex organization doing simple tasks has been replaced by a simpler organization doing more complex tasks. The agility and internal regulation of the group allows problems to be solved locally without propagation through a larger social space, thus increasing tempo. Halt tasks. Another concept in socio-technical theory is the halt task. A halt task has the advantage of placing responsibility for the task squarely on the shoulders of a single, small, face-to-face group which experiences the entire cycle of operations within the compass of its membership. The socio-technical embodiment of this principle is the notion of minimal critical specification. This principle states that, while it may be necessary to be quite precise about what has to be done, it is rarely necessary to be precise about how it is done. This is no more illustrated by the antithetical example of working to rule, and the virtual collapse of any system that is subject to the intentional withdrawal of human adaptation to situations and contexts. The key factor in minimally critically specifying tasks is the responsible autonomy of the group to decide, based on local conditions, how best to undertake the task in a flexible, adaptive manner. This principle is isomorphic with ideas like effects-based operations. Ebo asks the question of what goal is it that we want to achieve, what objective is it that we need to reach, rather than what tasks have to be undertaken, when and how. The Ebo concept enables the managers to manipulate and decompose high-level effects. They must then assign lesser effects as objectives for subordinates to achieve. The intention is that subordinates' actions will cumulatively achieve the overall effects desired. In other words, the focus shifts from being a scriptwriter for tasks to instead being a designer of behaviors. In some cases this can make the task of the manager significantly less arduous. Smiley face. Meaningfulness of tasks, effects-based operations, and the notion of a halt task, combined with adaptability and responsible autonomy, have additional advantages for those that work in the organization. This is because, for each participant, the task has total significance and dynamic closure, as well as the requirement to deploy a multiplicity of skills and to have the responsible autonomy in order to select when and how to do so. This is clearly hinting at a relaxation of the myriads of control mechanisms found in more classically designed organizations. Greater interdependence also bring with them an issue of size, in which the scale of a task transcends the limits of simple spatio-temporal structure. By this is meant conditions under which those concerned can complete a job in one place at one time, i.e., the situation of the face-to-face, or singular group. In other words, In classic organizations, the wholeness of a task is often diminished by multiple group integration and spatio-temporal disintegration. The group-based form of organization design proposed by socio-technical theory combined with new technological possibilities provide a response to this often forgotten issue, one that contributes significantly to joint optimization. Topics in socio-technical systems theory. Socio-technical system. A socio-technical system is the term usually given to any instantiation of socio and technical elements engaged in goal-directed behavior. Socio-technical systems are a particular expression of socio-technical theory, although they are not necessarily one and the same thing. Socio-technical systems theory is a mixture of socio-technical theory, joint optimization and so forth and general systems theory. The term socio-technical system recognizes that organizations have boundaries and that transactions occur within the system and between the wider context and dynamics of the environment. It is an extension of socio-technical theory which provides a richer descriptive and conceptual language for describing, analyzing and designing organizations. A socio-technical system, therefore, often describes a thing. Autonomous work teams, also called self-managed teams, are an alternative to traditional assembly line methods. Rather than having a large number of employees each do a small operation to assemble a product, the employees are organized into small teams, each of which is responsible for assembling an entire product. These teams are self-managed, and are independent of one another. Job enrichment in organizational development, human resources management, and organizational behavior, is the process of giving the employee a wider and higher level scope of responsibility with increased decision-making authority. This is the opposite of job enlargement, which simply would not involve greater authority. Instead, it will only have an increased number of duties. Job enlargement means increasing the scope of a job through extending the range of its job duties and responsibilities. This contradicts the principles of specialization and the division of labor whereby work is divided into small units, each of which is performed repetitively by an individual worker. Some motivational theories suggest that the boredom and alienation caused by the division of labor can actually cause efficiency to fall. Job rotation is an approach to management development, where an individual is moved through a schedule of assignments designed to give him or her a breadth of exposure to the entire operation. Job rotation is also practiced to allow qualified employees to gain more insights into the processes of a company and to increase job satisfaction through job variation. The term job rotation can also mean the scheduled exchange of persons in offices, especially in public offices, prior to the end of incumbency or the legislative period. This has been practiced by the German Green Party for some time but has been discontinued. Motivation in psychology refers to the initiation, direction, intensity and persistence of behavior. Motivation is a temporal and dynamic state that should not be confused with personality or emotion. Motivation is having the desire and willingness to do something. A motivated person can be reaching for a long-term goal such as becoming a professional writer or a more short-term goal like learning how to spell a particular word. Personality invariably refers to more or less permanent characteristics of an individual's state of being, as opposed to motivation. Emotion refers to temporal states that do not immediately link to behavior. Process improvement in organizational development is a series of actions taken to identify, analyze and improve existing processes within an organization to meet new goals and objectives. These actions often follow a specific methodology or strategy to create successful results. Task analysis is the analysis of how a task is accomplished, including a detailed description of both manual and mental activities. task and element durations, task frequency, task allocation, task complexity, environmental conditions, necessary clothing and equipment, and any other unique factors involved in or required for one or more people to perform a given task. This information can then be used for many purposes, such as personnel selection and training, tool or equipment design, procedure design and automation, job design or work design. In organizational development is the application of socio-technical systems principles and techniques to the humanization of work. For example, through job enrichment. The aims of work design to improve job satisfaction, to improve throughput, to improve quality and to reduce employee problems, e.g., grievances, absenteeism. Deliberations are key units of analysis in nonlinear knowledge work. They are choice points that move knowledge work forward, as originated and defined by Karl Popper in a second-generation development of STS theory. Deliberations are patterns of exchange and communication to reduce the equivocality of a problematic issue. For example, for systems engineering work, what features to develop in new software. Deliberations are not discrete decisions, they are a more continuous context for decisions. They have three aspects: topics, forums, and participants.